In this video, we're going to be looking at word problems that involve the perimeter of certain shapes. Recall that in order to find the perimeter of any polygon, you simply need to add all sides. All right, so if you're working with a triangle, you would add 3 numbers together. If you're working with a square, you'd add 4 numbers together. If you're working with a pentagon, you'd add 5 numbers together, etc. All right, but some shapes have simple formulas that you can use to find the perimeter. For example, if you're looking for the perimeter of a square, well, we know that every side of a square is the same, so take the value of one side and multiply by 4. Okay, so this means that P, the perimeter of a square, is 4 times S, whatever the side length of the square is. All right, if you're working with a rectangle, well, a rectangle, there's actually 3 different formulas that you would be able to use. Okay, so if we can think about a rectangle, all right, a rectangle we could say has a length of L and a width of W. Okay, and the sides that are across from each other have the same measurement. So that would be L, that would be W. So one easy way to find the perimeter of a rectangle, you could just do length plus width plus width. Add the 4 sides together, length plus width plus width. Or you could notice here that that's 2 lengths, so you could do 2 times the length and add it to 2 widths, 2 times the W. That also would give you the perimeter of a rectangle. Or what you could do is take the length and the width and add them together, and then whatever that sum is, take that entire sum and multiply it by 2. Perimeter equals twice the sum of the length and the width. Any of these 3 formulas would be good whenever you're trying to find the perimeter of a rectangle. All right, and we're actually going to find the perimeter of a rectangle in our first example. All right, so moving down here. It says that in a rectangle, the length is 3 feet less than 4 times the width. If the perimeter of the rectangle is 29 feet, then determine the dimensions of the rectangle. All right, and again, with our word problems, the first thing that we're going to do is write a let statement. All right, number 1, let's write our let statement. All right, so let's see if we can figure out which dimension we don't know anything about. They tell us that the length is 3 feet less than 4 times the width, but I don't know anything about the width. So I'm going to say let W equal the width of the rectangle. W is the width of the rectangle. Well, since I'm calling W the width and the perimeter, or excuse me, the length is based off of the width, I'm going to say the length is 3 feet less than 4 times the width. So I'm going to say 4 times the width minus 3 equals the length of the rectangle. Okay, so W is the width. The length is 3 feet less than 4 times the width, so 4W minus 3 has to be the length. Now let's see if we can set this problem up algebraically so that we can figure out the dimensions of the rectangle. Again, I've got 3 different formulas that I would be able to use to find the perimeter of the rectangle. I could add the length, the width, or I could do 2 times the length plus 2 times the width, or I can add the length and the width and then take that sum and double it. All right, why don't we go ahead and use this second formula? Again, I can use any of them, but I'm going to use that second formula. So I'm going to say 2 times the length. Well, the length is 4W minus 3. I need 2 times that entire expression. So 2 times 4 minus 3, that's the 2 times the length, plus 2 times the width, which I'm just calling W, equals the perimeter they told us was 29 feet. All right, there's our algebraic equation that we can use. 2 times the length plus 2 times the width equals the perimeter of 29. Let's see if we can simplify this left-hand side. First thing I'm going to have to do is use the distributive property here. 2 times 4W is going to be 8W, and 2 times negative 3 is going to be negative 6. So 8W minus 6 plus 2W is 29. Now I'll go ahead and combine my similar terms, 8W and 2W. 8W plus 2W is 10W minus 6 equals 29. And now I have a 2-step equation. Let's see if we can solve that. We'll isolate 10W by adding 6 to each side of the equation. When we do that, 10W is going to be equal to 35. And then if we divide each side by 10, that's going to tell us the width W. W equals 3 5/10. Okay, so we just figured out the value of the width W. The width W is 3.5. Let's see if we can figure out what the length is going to be. The length is 4W minus 3, which is going to become 4 times 3.5 minus 3. Okay, well, if you do 4 times 3.5, you're going to get 14. And then 14 minus 3 is 11. Okay, so let's see if those numbers work for our problem here. All right, the perimeter has to be 29 feet. If we do 2 times the length, which is 2 times 11, plus 2 times the width, which is 3.5, hopefully we get 29. 2 times 11 is 22, and 2 times 3.5 is 7. 22 plus 7 is 29. So this is going to work out. All of that is equal to 29. 29 equals 29. Wonderful. Okay, so now we can say here in our last step here, our little sentence here, the length is going to be, well, we just said that was the 11. The length is 11 feet, and the width, which was our W up above, is 3.5 feet. All right, the length of the rectangle is 11 feet, while the width is 3.5 feet. In our next example, we're told that the lengths of the sides of a triangle are consecutive odd integers. What is the length of the longest side if the perimeter is 45 inches? All right, so what we're going to do here, we're going to combine our perimeters with our consecutive integer word problems here. And in fact, we're looking at consecutive odd integers as the side lengths of our triangle. Okay, so again, the first thing that we need to do is go ahead and set up the let statement so that we know what we're working with here. Number one, let n equal the first side of the triangle. Okay, and then since the side lengths are consecutive odd integers are always 2 units apart from each other. So if n is my first odd integer, then I'm going to say let n plus 2 be my second side of the triangle, which is going to be my second odd integer. And then let n plus 4 be the third side of the triangle, or the third odd integer. Okay, so n plus 2, and n plus 4, they're consecutive odd integers, and they represent the side lengths of the triangle. All right, let's go ahead now and see if we can set this problem up algebraically. All right, so it says that the side lengths of the triangle are consecutive odd integers, and we're told the perimeter is 45 inches, and to find the perimeter, you add up all the sides. So n plus 2 plus n plus 4, those are the 3 side lengths of the triangle, have a perimeter of 45 inches. So there's our problem. On the left, we can clean this up. N plus n plus n is 3n, and 2 plus 4 is 6. 3n plus 6 is 45. All right, let's solve the two-step equation. We'll isolate 3n on the left by subtracting 6 from each side. All right, 6 minus 6 is 0, so 3n equals 45 minus 6, which is 39. And now if we divide each side by 3, that means that n is going to be 13. Okay, so that's the third thing we had to do, figure out the value of n. And now let's see if we can get the 3 side lengths of the triangle. N was the first side length, the smallest of the consecutive odd integers, so that's going to be 13. The second one, n plus 2, becomes 13 plus 2, which is going to be 15. And then the third one, n plus 4, becomes 13 plus 4, or 17. If I add these 3 numbers together, that should give me a perimeter of 45. So if we have 13, 15, and 17 and add those together, 3 plus 5 is 8. 8 plus 7 is 15. Carry a 1, 1, 1, 1, 1, that is 45. Okay, so I know that I have the numbers correct. And now they wanted to know, what is the length of the longest side? All right, so we can say here now in step 4, answering the question, the longest side of the triangle, is 17 inches. All right, the perimeter was 45 inches, so the longest side of our triangle is going to be 17 inches. Let's go ahead and practice with our perimeter and consecutive integer word problems here. And again, remember with your word problems, you're going to write a let statement. You'll set up your problem algebraically and solve it, and then you'll answer the question just by writing a short sentence. In our next example, the sum of 3 consecutive integers is 270. What is the middle number in this sequence? All right, so let's set the problem up. Number 1, first of all, the let statements. Let x equal the first integer. And then since they're just consecutive integers, they need to be 1 apart. So let x plus 1 equal the second consecutive integer. And then the third one is going to be 1 more than that. So let x plus 2 equal the third consecutive integer. All right, we're told that the sum of those 3 integers is 270. So what we're going to do when we set up our equation, we're just going to say the first, which is x, plus the second, which is x plus 1, plus the third, which is x plus 2. They all add up to 270. Looking at this now on the left, x, and x is 3x, and 1 plus 2 is 3. So 3x plus 3 is 270. And then what we're going to do, we're going to subtract 3 from each side, meaning that 3x is equal to 267. And then if you divide each side by 3, that will give you the value of x. All right, well, I'll move this over here where I've got a little more room. This is the third thing that I had to do. X equals 267 divided by 3 is 89. All right, x is 89. So let's see if we can figure out what the values of our numbers are. The first integer, x, we just said was 89. The second integer, x plus 1, becomes 89 plus 1, which is 90. And then our third one, x plus 2, becomes 89 plus 2, or 91. Adding these 3 numbers together should give us 270. 89, 90, and 91. Add them together. 9, 0, and 1 is 10. Carry a 1. 1 plus 8 is 9. Plus 9 is 18. Plus 9 is 27. So we do get 270. So now we can write our short sentence. We can say that the first integer is 89. The second integer is 90. And the third integer is 91. 89, 90, and 91 are 3 consecutive integers that add up to 270. In our next problem, we're looking for 3 consecutive odd integers such that 3 times the second number added to twice the third number is 7 times the first number. All right, so let's go ahead now and write our let statements. Let n equal the first odd integer. Since we're looking for 3 consecutive odd integers, n is the first one. Odd integers are 2 units apart from each other. So we're going to say let n plus 2 be the second odd integer. And then the third one has to be 2 more than that. So n plus 4 is going to be the third odd integer. Now let's make our equation. All right, reading the words carefully, we're told that 3 times the second number, right? The second number is n plus 2. So 3 times n plus 2, we'll put that in parentheses, added to twice the third number. The third number is n plus 4. 2 times n plus 4. 3 times the second number added to twice the third number equals 7 times the first number, which we've called n, 7n. So there's our equation. Let's go ahead and see if we can solve it. On the left-hand side, the first thing I'm going to have to do is distribute. 3 times n is 3n. 3 times 2 is 6, 3n plus 6, plus 2 times n is 2n. 2 times 4 is 8. 2n plus 8 equals 7n. Let's simplify the left-hand side. 3n and 2n is 5n, and 6 and 8 makes 14. So 5n plus 14 equals 7n. Now we'll get the variables on one side. I'm going to subtract 5n from each side. So 14 equals 2n. And now if we divide each side by 2, we're going to know in step 3 here that 7 equals n. Our value of n is 7. So now let's see if we can get our integers. They needed to be odd integers, so I'm off to a good start here. The first one, n is 7. The second one, n plus 2, becomes 7 plus 2, which is 9. And the third one, n plus 4, becomes 7 plus 4, which is 11. Let's see if these numbers work with our problem. All right, 3 times the second, 3 times 9, plus twice the third, 2 times 11, equals 7 times the first, which is 7 times 7. 3 times 9 rather is 27, plus 2 times 11 is 22, equals 7 times 7, which is 49. And 27 plus 22 is 49. 49 equals 49, so the numbers work. All right, so let's write down what those numbers are. Step 4, the first odd integer. The first odd integer is 7. The second odd integer is 9. And the third of our odd integers is 11. 7, 9, and 11 are the 3 odd integers in this problem. In our next example, we're told that the perimeter of a rectangle is 28 centimeters. The length of the rectangle is 2 centimeters more than twice the width. What are the dimensions of the rectangle? So we'll set up our let statements here at the beginning. Let, all right, and then which dimension don't we know anything about, the length or the width? Well, they said that the length is 2 centimeters more than twice the width, but I don't know anything about the width, so I'm going to say let W equal the width of my rectangle. And then since W is my width, the length is 2 more than twice the width. So 2W plus 2 must be the length, all right? 2 more than twice the width. That is the length. Now let's go ahead and see if we can make an equation to represent this problem. Step 2. The perimeter is 28 centimeters. And remember, for a rectangle, you can say 2 times the width plus 2 times the length equals the perimeter. All right, the perimeter is 28 centimeters, twice the width, 2W, plus twice the length, 2 times 2W plus 2 is 28. Let's go ahead and simplify this left-hand side. I have to first distribute here with this 2. So I'm going to bring down 2W plus 2 times 2W is 4W, and then 2 times 2 is 4. So 2W plus 4W plus 4 is 28. 2W and 4W is 6W when we combine the similar terms. And now we have our two-step equation. 6W plus 4 is 28. We'll isolate 6W by subtracting 4 from each side. That means that 6W is 24. And if you divide each side by 6, then W must equal 4. That's the third thing that we needed to do. Now let's get our dimensions. W, the width, W is 4. The length, 2W plus 2, becomes 2 times 4 plus 2, which becomes 8 plus 2, or 10. All right, so if I were to find the perimeter, would those numbers work? Well, again, the perimeter was 28. Is that 2 times the width plus 2 times the length? Well, 2 times 4 is 8, and 2 times 10 is 20. Well, yeah, 8 and 20 definitely makes 28, so our numbers work here. So now let's write our sentence. The width of our rectangle, the width is 4 centimeters, and the length was here at the end is 10 centimeters. Our rectangle is 4 centimeters by 10 centimeters.